25 years ago, this was the view astronomers had of the cosmos. Then came the Hubble Space Telescope. Suddenly, the true wonder of the universe appeared before our eyes. Delicate structures, vivid colours, and objects of staggering beauty.
Tonight, we celebrate a telescope that's changed our view of the universe as we reveal the Sky at Night's top 5 Hubble images.
Welcome to the Hurst-Monceau Observatory, former home to the Royal Observatory Greenwich. The story of this place plays a part in the story of how the Hubble Space Telescope came to be. It was all about astronomers' search for the best views of the cosmos.
The domes behind us contain 4 of the largest telescopes in Britain, moved here from Greenwich in the 1950s and 60s. They came to escape the city lights and get a better view of the night sky.
But soon it was realised that even this remote site wasn't good enough. Observing was limited by the British weather.
The ultimate site for astronomy is up above the Earth's atmosphere, getting away from its distorting effects altogether. And that was achieved when Hubble entered orbit 25 years ago. Coming up, how Hubble came close to disaster. Chris Riley investigates.
NASA's entire credibility and that of the whole US space program was called into question.
Pete reveals how you can take your own Hubble images.
Beautiful, the Horsehead Nebula.
And we'll reveal the Sky at Night's #1 image from the world's preeminent space observatory.
To compile our top 5, each member of the Sky at Night team voted for their favourite images. We've tallied the results, and it comes up with a very varied list.
The top 5 includes images that are inspiring and beautiful, but also those that have pushed science to new boundaries, expanding our knowledge of the universe in surprising and profound ways.
So let's get started and see what's on our top 5.
In at number 5 is a Hubble classic. An image that captures the remnants of a dead star, the Crab Nebula. This image was captured by Hubble in 1999, and it shows a special kind of nebula, a supernova remnant, all that remains of a star that exploded centuries ago. The complex structure is the result of a shock wave expanding at 1,000 kilometers per second, carrying gas and dust along with it. As with many Hubble images, the colours that you see here aren't the ones you'd see with your own eyes, but they are meaningful. They represent what Hubble sees in different wavelengths of light. But there's more to this image. Hidden in the heart of the nebula is a pulsar, the dense rotating core of the star that exploded. It's only 12 miles wide, but it's got a mass greater than that of the Sun. And it's the astonishing resolution of Hubble's cameras that let us pick out these fine details. I still find it remarkable that Hubble can show us things moving in an object like the Crab Nebula. Here we can see clouds scudding across an area 3 or 4 times larger than our own solar system. And of course, it's not just the Crab. Hubble has looked at many supernova remnants over the years.
Today, we take Hubble's extraordinary images for granted. But when the telescope was first launched, it was rocked by a series of disasters that threatened to turn Hubble into a billion-dollar flop. Space historian Chris Riley investigates how NASA set about saving Hubble from the jaws of disaster.
T-6, 5, 4...
On the 24th of April 1990, the Hubble Space Telescope was launched from Cape Canaveral.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, a window on the universe.
And placed into orbit 550 kilometers above the Earth. Back on the ground, scientists eagerly awaited the first images. But as they came in, it was clear something was wrong. Instead of the sharpest, clearest images ever taken of the universe, Hubble sent back a series of blurry shots. An investigation was immediately launched. To everyone's horror, it revealed that the fault lay with the giant primary mirror, the most important component of the telescope and the most difficult to fix. It might seem hard to believe now, but Hubble's flaw was so fundamental in nature, this was such a basic failure of project management, that NASA's entire credibility and that of the whole US space program was called into question. And the agency came under immense pressure to try and repair the telescope and its own reputation. The mirror on Hubble plays the same role as a lens, magnifying and focusing the light. To work, it needed to be perfect. But despite almost 3 years of polishing, it had a slight flaw. I've come to UK telescope mirror manufacturer Zico to find out what happened to Hubble. So what went wrong with Hubble's mirror?
The mirror itself was polished well. The machine that did the polishing was good. It was the measurement of the mirror was not correct. So this resulted in a perfect mirror almost. It was a very, very high quality result they achieved. But the shape of the mirror was wrong, which means that the rays coming from the stars and the cosmos were not focused to a fine enough image.
On Earth, the standard way to fix the mirror would be to repolish it, but that was impossible in orbit. A completely new fix was needed. The solution was ingenious. What the scientists realized was that if they could recreate the flaw in Hubble's primary mirror, but in reverse, perhaps they could cancel out the effect and produce focused images. So they built a new camera with 4 tiny relay mirrors, all with this reverse flaw incorporated. For the engineers, this was a painful process. They never had to design something that was intentionally flawed. The same principle used to fix the camera was also employed to create a totally new device, one which would correct the light for all the other instruments on board Hubble. It was precision engineering, but of course all this equipment was constructed on Earth. Now it needed to leave the planet and join Hubble in space. Repairing Hubble would require one of the most audacious space shuttle missions ever conceived. 5 long spacewalks would be conducted over 5 consecutive days. In terms of complexity and ambition, nothing like this had ever been attempted. To pull it off, the NASA astronauts spent over a year undertaking the most immersive training program to date. Telescope mock-ups were submerged in a neutral buoyancy tank. Logging more than 200 hours underwater, the astronauts repeated the hundreds of complicated maneuvers required to fix the telescope until they became instinctive. On the 2nd of December 1993, the mission to repair Hubble launched.
And we have liftoff.
So, Houston, let's go fix this thing.
2 days later, astronauts Jeff Hoffman and Story Musgrave stepped out the door.
Going out the door, it is just awesome. I mean, it is flat frightening. And I was scared. I was scared pre-flight and I was scared in flight.
Cocooned inside their spacesuits to do this repair work was an exhausting task, and handling tools through their thick spacesuit gloves, like this Russian one here at the National Space Center in Leicester, was likened by astronaut Jeff Hoffman to doing brain surgery whilst wearing welder's gloves. And I can see what he means. It's very hard to get any sensation of touch through your fingertips, and doing any dexterous, fine work must have been close to impossible. Spacewalks are never routine, and the Hubble rescue mission was going to be harder than most. There was already a serious concern when it came to installing the new optical device.
HAT, I'm getting ready to take it off. You have it? I have it.
A process that had been problematic in training as the mock-up didn't quite fit. Would the same problem occur with the real telescope?
It would just kind of cross your fingers, hope things were built according to the way the drawing said they were built, that no changes were made after the drawings, and that the thermal environment it was in hadn't changed anything.
Back on the ground, the team at Mission Control held their breath. Carefully, astronaut Kathy Thornton manoeuvred the new optical device into place.
It's a very big box going in a very small hole with about an inch of clearance going in, and then obviously the clearances got tighter.
Thankfully, it was a perfect fit.
Good work, guys.
But something else, completely unforeseen, put everything in jeopardy. A simple service hatch refused to close.
So we're out by about 1 centimeter. Copy. Same story. Do you have the handle latch closed? We're about to. But wait a minute, the bottom one isn't coming right. We gotta go and work on that.
Even the slightest chink of light getting inside the telescope would render it useless. The astronauts had to get the latch to lock.
Houston, if you copy, Jeff's just working, putting the doors back together and thinks he's found a way that seems to close the gap. And we're going to try that, if that's okay.
Press on. If you've got a way to do it, do it.
Using a strap and a ratchet, a free-floating Story Musgrave improvised a solution. It was a success. The astronauts were elated. But now scientists on the ground had to wait for the first images. On New Year's Eve 1993, they came in. What was a blur was now crystal clear, and our view of the cosmos was changed forever.
Now, back to our countdown. Number 4 is occupied by the Carina Nebula. It's located in the southern hemisphere constellation of the same name. To Hubble's eyes, it looked more like a Turner painting than a photograph of a real phenomenon. The Carina Nebula is a huge cloud of dust and gas, some 300 light years across. That's 7.5 times the size of the Orion Nebula. This massive tumultuous cloud is essentially a giant stellar nursery. Now, Hubble has taken many striking images of nebulae like this, including the iconic Pillars of Creation, or the Horsehead Nebula, which nearly made it into our top 5 in their own right. But the Carina Nebula is one of the biggest star formation regions in the galaxy, which makes it the perfect laboratory for studying the birth of stars. A composite of 48 frames taken by Hubble's advanced camera for surveys reveals unique detail, giving us a treasure trove of amazing astronomical objects. There is Eta Carina, a star system and nebula in its own right that houses one of the most massive stars documented. And there are the astonishing silhouettes of dark dust pillars, backlit by the brightly shining gas. It's all here in the Carina Nebula. On with the countdown. The image with the third most votes from the Sky at Night team is the Hubble Deep Field. Taken in 1995, Hubble was pointed for 10 days at a patch of sky that appeared to be empty. Instead, it revealed an area teeming with ancient galaxies. The Hubble Deep Field has been described as one of the most important images ever taken because it gives us an understanding of the scope of our amazing universe. What makes the Deep Field so revolutionary is that it allows us to look back in time, over 12 billion years to the very early universe. Chris is speaking to Sarah Kendrew, looking at the impact of these deep field images.
So Sarah, tell us how the Hubble Deep Field came about.
The Hubble Deep Field, scientists had basically proposed to look at an empty patch of sky. So that's quite an unusual thing to want to do.
It seems crazy.
Right, because they had no idea what they were going to find. So it's quite hard to justify, but ended up being incredibly successful and became the iconic image for the Hubble Space Telescope.
Yeah, I was just going to use that word. It really is a stunning image, and we can look at it here. What exactly are we seeing in the deep field?
So it's a relatively small patch of the sky that was specifically selected for not having many sort of stars in the galaxy in the foreground. But what we can see is that all this light comes out from the background, and every single point of light in this image is an individual galaxy.
But of course, this isn't the local universe, so we're seeing these galaxies as they were many billions of years ago as well.
That's correct. We have a whole range of galaxies in this image. Some of them are nearer to us, but we're also probing down to the first billion years of the universe's existence. And that really was very new. It really gave us, for the first time, this quite large sample of galaxies from the very early universe. And we can take a closer look at them.
So the ultra-deep field, which came a bit later, was sort of the improved version. But these galaxies look different from the ones we'd see today.
That's right, and that's one of the main outcomes of the Hubble Deep Field. Galaxies in the early universe, have quite a different appearance. Whereas the galaxies we see in the universe today tend to be quite ordered, they have a nice spiral shape, or they're blobby elliptical galaxies. These are much more irregularly shaped. So you can see, for example, some galaxies that are merging together. And that makes sense because the universe was much smaller in those early days before the expansion had really kind of grown it to a larger size. So the small galaxies were more densely packed, and so they would collide to then sort of form bigger structures. So that's really an outcome of this image.
So why couldn't you do this from the ground? Why do you need a space telescope to take this sort of deep field?
Well, the problem we have on the ground is that the Earth is surrounded by the atmosphere, which is basically a dense coating of turbulent gas. And that really distorts light as it comes in from space. And so it's very hard to get images with this kind of fine detail that we can see with the Hubble Space Telescope.
We get a blurred view from the ground.
You get a very blurred view, especially over very long exposures. The light will become, quite blurred, and you don't get these beautiful images. And that was really very new for the Hubble Space Telescope to be able to achieve this.
Hubble will be around a little while yet, but it is coming to the end of its life. What comes next?
So the successor to the Hubble Space Telescope is getting really close to its launch now. It's called the James Webb Space Telescope. It's a much bigger telescope than Hubble. So its mirror has a collecting area that's 7 times larger than that of Hubble. So it's just going to be able to catch an awful lot more light than Hubble, specifically to be able to push further into the early universe and see the very first galaxies that formed.
Well, to do that, it has to work in the infrared.
That's right, because the light from distant galaxies gets stretched to longer wavelengths. So to be able to observe further and further back in time, we need to be able to go further and further also along in wavelengths.
You mentioned that you're involved in one of the instruments for James Webb, and that gives you some say in what the telescope might look at. What are you particularly excited about seeing?
What I'm particularly interested in is looking at the galaxies that are a bit nearer to us. We already know these galaxies are there, and we know that they're forming stars at an incredibly vigorous rate. So that's something that will be very exciting, to really see how that star formation is triggered and how it's shut down, and how these galaxies are sort of converting their material into new stars.
Well, we'll look forward to seeing the results. Sarah, thank you very much.
Still to come, we reveal our #1 Hubble image. But first, Peter's here with his guide to taking your own versions of iconic Hubble images.
Hubble certainly takes some of the best and most spectacular images of the cosmos, but many of its iconic targets are also within reach of amateurs too.
Take the Orion Nebula. It can be amazing through a telescope and is easy to photograph with a stills camera. Orion is now heading out of view, so how about creating your own version of the famous Pillars of Creation by imaging the Eagle Nebula?
You can see the famous pillars here in this image. They are the features which give the Eagle Nebula its name. The one in the centre is supposed to represent the eagle's body. Then we've got the wing down here, and he's carrying a fish up the sky. Now, marvellous though the colours are that we're looking at here, they're not the colours you'd see with the human eye, but rather they're peculiar to the way that Hubble images are constructed.
Hubble takes images in a very particular way. Its cameras are actually black and white, so to create a colour image, Hubble takes multiple shots of the same object through different filters. Each are assigned a colour. When combined, they create a rather distinctive colour scheme known as the Hubble palette, and it's possible to do this yourself with the right filters.
The aim here is not to try and create a photograph which looks natural to the human eye, but rather to create one which picks out features emphasised by certain elements. Now, to demonstrate how striking this effect can be, here is a Hubble palette version of the Rosette Nebula, and you can see lots and lots of fine intricate detail here. But if I switch to the normal view, you see a lot of that detail is lost.
I've come to meet some of the members of the Breckland Astronomical Society who've been capturing some iconic Hubble targets.
Richard.
Hello.
That's a very recognisable object there. That's the Crab Nebula, isn't it?
Yes, it is. Yes. Yeah.
So did you take that?
Yeah, I took that myself, just with my amateur kit.
Well, that's a great result, isn't it? That's you've got loads of detail in there, loads of little filaments and whatever. I mean, Hubble obviously does it better, but
of course.
that is quite something for somebody to grab. Yes, this is the one I've been looking for. It's beautiful. The Horsehead Nebula and the Flame Nebula there as well. Incredible, because I remember the first time I ever took a photograph of this region and looking for the horse's head, and it's difficult to see it. It's just there hiding in the background. But to actually tease it out and bring it out.
That's right. I remember the first time I imaged it as well, and it was just barely visible.
Right, okay.
With the equipment now, it's fairly easy.
Thank you very much, Malcolm.
Thank you.
Amazingly, these days it's even possible for serious amateurs to have a go at recreating the Hubble Deep Field, which makes a nice challenge.
I want you to go out, if you've got serious kit, and try and get a photograph of that iconic area of the sky and see what you get back. If you do get anything, then send it up to our Flickr group, which is at bbc.co.uk/sky@night, and we'll put the best ones in a gallery.
So if you fancy having a go at imaging the Hubble Deep Field, here's how to find it. First, locate the plough. Imagine an equilateral triangle using the stars Megrez and Alioth at its base. The triangle points to two stars on the threshold of naked eye visibility. We've marked these as A and B. Extend the line from A through B for the same distance again. Now turn by a right angle and head down towards the plough. This points to a patch of sky with nothing in it, and it's the location of the Hubble Deep Field.
Back to our countdown, and we've reached number 2. A striking image of the largest planet in the solar system, Jupiter. And amongst its bands and spots can be seen several dark marks. Scars from the impact of comet Schumacher-Levy 9.
I always like to think of Jupiter as our big brother in space. It's absolutely enormous, 300 times the mass of Earth, and it's that enormous mass that absorbs some of the impacts that could otherwise wipe out our existence. That was theory, until we saw these amazing images, which showed the impacts that our big brother is absorbing on our behalf.
In July 1994, 21 fragments of what was the comet Schumacher-Levy 9 crashed into the atmosphere of Jupiter, and Hubble was on hand to witness the event. The impacts happened just over the limb on the planet's far side, though the plumes were detected from Earth. But the true enormity of what had happened became apparent slightly afterwards, as Jupiter rotated, bringing the impact sites into Hubble's view. The wonderful thing about this event was that no one had any real idea what to expect. We hoped we might see the impacts with Hubble, but that was about it. And I remember going outside with my own small telescope and being able to see these bruises on Jupiter's surface, and then to see the Hubble images afterwards made for a really thrilling event.
The resulting impacts were more profound than anyone had predicted. Using different wavelengths of light, Hubble captured striking images of the impact scars, revealing some to be twice the size of Earth. These images turned out to be a boon for scientists because they dragged out chemicals from deep below and gave us a window into Jupiter's atmosphere.
We're reaching the end of our countdown, but we still want to hear about your favourite Hubble images. So send us your selection via Twitter using the hashtag HubbleTop5.
Before we reveal our number 1, here's a recap of the Sky at Night's top 5. At number 5 is the dying embers of an exploding star, the Crab Nebula.
At number 4, that kaleidoscope of colour, the Carina Nebula.
Number 3 is a look back in time with the Hubble Deep Field.
And at number 2, a comet's collision with Jupiter. And that just leaves our number 1 image. It's an image I didn't think would come out on top. I don't think any of us did, but it's this one. V838 Monocerotis. V838 is an extraordinary evolving structure in the constellation of Monoceros. The light comes from a mysterious outburst on a star which created a flash 1,000,000 times more luminous than the Sun. And what we're seeing is that light bouncing off the surrounding dust, what we call a light echo. There aren't many astronomical objects that change before your eyes, and few that do so with such beauty and drama. The source of the explosion was a giant red star that suddenly brightened. And it's the journey that light took that captivates.
The flash occurred in 2002, briefly making V838 the brightest star in the Milky Way. Since then, the light has been expanding outwards, bouncing off rings of dust surrounding the star. We can actually see the light of the explosion spreading out as it illuminates the clouds around it.
What I love about this sequence of images is that it reveals the hidden side of space. There's all this stuff, all this dust out there just waiting to be lit up. And watching the sequence also reminds us how long it takes light to travel across the vast, empty distances of space.
I find this object absolutely captivating. It looks as if it's expanding right in front of our eyes, even though it's just the light travelling through. But what caused this explosion, and why does it look this way? I've been speaking to Jacco van Loon. Jacco, these images of 838 are absolutely fantastic, but can you tell me what's going on?
This is an object that erupted, so all of a sudden it became a bright object. It lasted a couple of months, and then it faded. Afterwards, it erupted again, and once more after that, and that's very unusual. Usually you see a single explosion and then it fades.
So do you know a mechanism to explain this sort of phenomena?
Yeah, various astronomers know mechanisms. They don't all agree.
A mystery.
They include, for instance, the merge of two stars. Another possibility is a nuclear explosion inside a star, perhaps, or on the surface of a star.
So what has been left behind after these multiple explosions?
Well, we can't see that at the moment, because shortly after the eruption, there was a very dense shell expanding, but dust formed in it and obscured whatever happens inside. So at the moment, it's waiting for the dust to clear and see what's left behind.
So at some point, we'll actually be able to see, yes, what remains. But what sort of timescale? Usually on astronomical levels, things are pretty long.
Well, what remains, if anything, of course, we expect it to happen on timescales of years. So within our lifetime.
Well, it sounds fascinating, and I can't wait to see what lies behind the dust. Thank you very much for talking to me.
You're welcome.
Hubble's expected to remain operational until at least 2020, so there's plenty of great science to come, and James Webb will provide wonderful images and science in the infrared. But astronomers are already planning for the next generation of great optical space telescope.
But Hubble still has some treats to come. In the next few weeks, the team has promised the release of a special image to celebrate the telescope's birthday. So keep a lookout for that one.
Next month, we'll be exploring our nearest neighbour, Venus, and finding out what makes Earth's twin such a different place from our own world.
Remember, send us your Hubble Top 5 to the Twitter account at BBC Stargazing. In the meantime, get outside and get looking up.
Good night.